Good morning, students. We have been discussing the various methods to solve a differential equation. So, for the last three videos, what I mean is lecture number 16, 17 and 18, we have been discussing the linear differential equation. So, before watching this video, students were requested to watch those videos, and we have started the exercise 8E, which is based on the linear differential equation, and we have solved first and second Romans and third Roman. We have discussed all the problems except the three problems that is based on the Bernoulli's differential equation. But before we start the Bernoulli's differential equation, let us discuss the examples from the textbook, page number 347, 348, 349 and 350. After you get in touch with this concept, then we will proceed with this Bernoulli's differential equation. So first, these are the problems from 347, 348, 349 and 350 pages from the textbook. So the question is, transform the following differential equations into a linear form. So a linear differential equation can be one of the two forms, dy by dx plus py equals to q, where p comma q are the functions of a x or constants. Or another form is dx by dy plus px equals to q, where p comma q are either constants or functions of y. So now these are we have to transform these differential equations into linear form. So first, the coefficient of dy by dx should be 1, for which let us divide the entire equation with x log x on both the sides. Then we'll get dy by dx plus y by x log x is equals to 2 log x by x log x. So log x gets cancelled, and here dy by dx equals to plus 1 by x log x into y is equals to 2 by x. This is clearly of the form dy by dx plus py equals to q, where p comma q should be in terms of the independent variable x. Here p is in terms of x and q is in terms of x. P is equals to 1 by x log x and q is equals to 2 by x. So we have done with this problem. So we are done with this problem. And now x plus 2y cube times dy by dx equals to y. So first of all, dy by dx equals to y by x plus 2y cube. So we cannot do any further from this step onwards. So for which let us reciprocate it. Dx by dy equals to x plus 2y cube by y. So this is equals to dx by dy is equals to x by y plus 2y cube by y square times. This is equals to dx by dy minus x by y equals to 2y square. Therefore, dx by dy plus minus 1 by y into x equals to 2y square. So this is clearly of the form dx by dy plus px equals to q, where dx by dy plus px equals to q, where p is equals to minus 1 by y and q is equals to 2y square. Find the integral factor of the following differential equations by transforming them into linear form. First, we need to transform in the linear form, one of the two linear forms, dy by dx plus py equals to q, or dx by dy plus p x equals to q. First one's integral factor is e power integral p dx, and next one's integral factor is e power integral p dy. So first of all, let us try to convert. So here the coefficient of dy by dx is cos x, for which we need to divide by cos x. Dy by dx plus y sin x by cos x is tan x is equals to tan x is sin x by cos x into 1 by cos x. This is clearly of the form dy by dx plus tan x into y is equals to, so tan x into secant x. So this is clearly of the form dy by dx plus py equals to q, where p is equals to tan x and q is equals to tan x into secant x. So now integral factor is equals to its integral factor is e power integral p dx. E power integral p is tan x dx. Integral tan x dx is log mod secant x. Log modulus of secant x. Here e power log f of x is f of x. Therefore this is secant x. Therefore this is the integral factor for this linear differential equation. This is equals to dy by dx equals to minus y by 2x minus 10 by q. So this cannot be reduced any further, for which let us take dx by dy, which is equals to 2x minus 10 by q by minus y, and this is equals to dx by dy equals to 2x by minus y minus by minus plus 10 by cube by y square times. So this is equals to dx by dy plus, this is 2x by y. So this is 2 by y into x is equals to 10 y square. This is of the form dx by dy plus px equals to q. This is the form number 2. Dx by dy plus px equals to q, where p is equals to 2 by y. So integral factor is e power integral p dy. So e power integral 2 into 1 by y dy. So this is equals to 2. Integral 1 by y dy is log y. So this is 2 log y can be written as e power log y square. That is equals to y square is the integral factor. Solve 1 plus x square times dy by dx plus 2xy minus 4x square equals to 0. So here he is asking to solve this. That means we have to arrive for the general solution. Dy by dx, let us divide this by 1 plus x square, then dy by dx plus 2x by 1 plus x square times y. This minus 4x square, if you transpose onto another side and divide with this, then we will get 4x square by 1 plus x square. This is clearly of the form dy by dx plus py equals to q. P is equals to 2x by 1 plus x square. So, and q is equals to 4x square by 1 plus x square. Integral factor is equals to e power integral p dx. 2x by 1 plus x square dx. So e power, this is 1 plus x square derivative is 2x. This is of the form f dash x by f of x. Integral f dash x by f of x is log mod f of x. F of x is this. This is log 1 plus x square. This is equals to 1 plus x square. This is our integral factor and general solution is, so y into integral factor is equals to integral q into integral factor into dx. So this is equals to y into integral factor is 1 plus x square. Q is equals to 4x square by 1 plus x square into integral factor is 1 plus x square dx. This gets cancelled. So 4 into integral x square dx is x power 2 plus 1 by 2 plus 1, which is x cube by 3 plus c. Therefore, 1 plus x square into y is equal to x cube by 3 plus c is the required solution. Solve 1 by x dy by dx plus y into e power x equals to e power 1 minus x into e power x. This e power x is on the power of this e. So as usual, first let us divide the entire equation with the x. Then x by x is 1. So the coefficient of dy by dx will become 1. So dividing by
multiplying
x on both sides. Then we'll get dy by dx plus xy e power x equals to x into e power 1 minus x into e power x. So this can be written as dy by dx plus x into e power x into y is equals to x into e power 1 minus x into e power x. So this is clearly of the form dy by dx plus py equals to q, where p is equals to x e power x, q is equals to x into e power 1 minus x into e power x. So integral factor is equals to e power integral p dx. So this is e power integral p dx is x e power x dx. So e power, this is product of two functions. Product of two functions. So we need to integrate it through the process of by parts. Highlight phrase will come to our mind. So x is algebraic function, e power x exponential. So highlight a comes first and then e. So this is equals to first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So this is equals to e power x into integral e power x dx is e power x only minus d by dx of x is, this is 1 into integral e power x dx is e power x into dx. This is equals to e power, so this is x e power x minus 1 into e power x is e power x. Integral e power x dx is e power x only. So this is equals to e power. So in both of them, let us take e power x as common. In both of them, let us take e power x as common, then we will be left with x minus 1. This is our integral factor. Now general solution is, so y into integral factor is equals to integral q into integral factor into dx. So this is y into integral factor is this e power x into x minus 1 is equals to q is x into e power 1 minus x into e power x into integral factor is e power x into x minus 1 dx. So this is equals to x into, so this is equals to here e power. So bases are equal, exponents are to be added. So e power, so this is equals to 1 minus x into e power x plus e power x into x minus 1 dx. So this is equals to x into e power. So let us multiply each and every term. So this is equals to 1 into e power x is e power x minus x into e power x, x e power x plus this is x e power x plus into minus minus e power x into 1 is e power x dx. This is equals to x into e power x gets cancelled, x e power x gets cancelled. So this is e power 0 dx. X into e power 0 is e power 0 is 1. So x into 1 is x dx is x square by 2 plus constant of integration c. Therefore, y into e power x into x minus 1 is equals to x square by 2 plus constant of integration c. This is equals to 2y into e power x into x minus 1 is equals to x square plus 2c. So I have taken the LCM and I just transposed on to another side. This is what we get ultimately as the required solution. Solve sin square x into dy by dx plus y equals to cot x. Let us divide by sin square x. Dividing by sin square x on both sides. This is equals to dy by dx plus y by sin square x is cosecant square x is equals to cot x by sin square x, which is again cosecant square x. So here it is of the form dy by dx plus py equals to q, where so y same, therefore in the place of p we can find cosecant square x, where p equals to cosecant square x. So and q is cot x into cosecant square x. Integral factor is equals to e power integral p dx. Integral cosecant square x dx. Integral cosecant square x dx is minus cot x. Now, general solution is y into integral factor is equals to integral q into integral factor into dx. So, y into integral factor is e power minus cot x. Q is cot x into cosecant square x into integral factor is e power minus cot x dx. Now, cot x derivative is minus cosecant square x. That's why let minus cot x is equals to t I take. Then cot x derivative is minus cosecant square. Minus of minus plus. cosecant square x dx is equals to dt. So this is equals to integral cot x. Cot x is t minus cot x is equals to how much here? Minus t. Minus cot x is t. Multiply minus on both the sides, then cot x equals to minus t. Now cosecant square x dx is dt. Cosecant square x dx is dt into e power minus cot x is t. So this is what we have obtained, e power minus cot x equals to, this is minus of t e power t dt. So minus, I'll separate from the process of integration, I'll take it out, t e power t dt. So last problem we have seen, integral x e power x is x e power x minus e power x. E power x, if you take common, x minus 1. Here e power t into t minus 1. So this minus will be here itself plus constant of integration c, because since x e power x dx is equals to x e power x minus e power x plus c. So that is why take e power x common, x minus 1. Here e power t, if you take common, t minus 1. So this implies y into e power minus cot x is equals to minus, the value of t here is minus cot x. So e power minus cot x, t value is minus cot x minus 1. Minus cot x minus 1 plus constant of integration c. This is equals to, so minus e power minus cot x minus, if you take common, then minus of minus plus will be left with 1 plus cot x plus constant of integration c, y into e power minus cot x is equals to. So therefore this e power minus cot x, if you bring on to another side, y is equals to e power minus cot x by e power minus cot x gets cancelled. So we are left with 1 plus cot x plus c by e power minus cot x. 1 by e power minus cot x, if you take to the numerator, this is c into e power plus cot x is the required solution. Find the solution of the equation x into x minus 2 times dy by dx minus 2 into x minus 1 into y equals to x cube into x minus 2. Had it been asked to that only, then actually whatever we have been doing, so the general solution is what we are going to get at the end. But this problem is a little bit different from the other problems, because here will satisfy the condition y equals to 9 and y equals to 3. So here x and y values are given. Whatever the values that we are going to get ultimately, which is the general solution, substituting this x and y in that general solution will get the particular solutions. He is asking us the particular solution. So let us find solution. So dividing by x into x minus 2, we get, so this is dy by dx minus 2 into x minus 1 by x into x minus 2 y is equals to x cube into x minus 2 by x into x minus 2. X minus 2 gets cancelled, x square times. So this is the form dy by dx plus, this is minus 2 into x minus 1 by x into x minus 2 times y equals to x square. So this is of the form dy by dx plus p y equals to q. Therefore p is equals to minus 2 into x minus 1 by x into x minus 2 q is equals to x square. So the integral factor is e power integral p dx. E power integral p is this minus 2 into x minus 1 by x into x minus 2 dx. So to solve this, let us consider this separately, and since it's a fraction p by q where the degree of the numerator is 1 and the degree of denominator is 2, so degree of numerator is less than that of degree of denominator, therefore this is a proper fraction. Partial fractions can be applied. So here x and x minus 2 are two non-repeated linear factors, therefore it can be expressed as a by x plus b by x minus 2. So since x and x minus 2 are the factors equated to 0, x equals to 0, and x minus 2 equals to 0, x equals to 2, x equals to 0 and 2, if you substitute in the equation, we will obtain the values of a and b. So let us do that. Consider 2 into x minus 1 by x into x minus 2. This is equals to a by x plus b by x minus 2. So this is equals to 2 into x minus 1 by x into x minus 2 is equals to a into x minus 2 plus b into x by x into x minus 2. I have found the LCM. So x into x minus 2 on both the sides gets cancelled. So this is equals to 2 into x minus 1 is equals to a into x minus 2 plus b into x. Put x equals to 0. This is equals to 2 into 0 minus 1. So this is minus 1. This is 0 minus 2. So minus 2 into a, minus 2a. So b into 0, 0. So this is equals to minus 2 equals to minus 2a. Therefore a equals to 1. Likewise, put x equals to 2. We'll get 2 into 2 minus 1, 1. So 2 minus 2, it will be 0. So b into 2. So 2 gets cancelled. Therefore, b equals to 1. So a equals to 1 and b equals to 1, we get that. Therefore, 2 into x minus 1 by x into x minus 2 is equals to a by x, which is 1 by x, plus b by x minus 2. b is 1 by x minus 2. Now, so e power integral dx is nothing but e power integral dx. And here minus we have left. So I'll take minus also into consideration. So this is equals to e power minus. This is integral 1 by x dx is log mod x plus integral 1 by x minus 2 dx is log mod x minus 2. So this is equals to e power minus log a plus log b, log ab x into x minus 2. So this can be written as, this is minus can be written as minus 1. So m log a, log a to the power of m. So this is e power log x into x minus 2 whole power minus 1. So e power log gets cancelled. X into x minus 2 whole power minus 1 is 1 by x into x minus 2 is the integral factor. So far we get there. So the general solution is y into integral factor equals to integral q into integral factor into dx. Y into integral factor is 1 by x into x minus 2 is what we have got before, is equals to q is x square, integral factor is 1 by x into x minus 2 dx. Here This x and this x get cancelled. Here this is x by x minus 2 dx. This is again a improper fraction where degree of numerator and denominator is 1. So let us divide x by x minus 2. Instead of that, we can even adjust. X can be written as x minus 2 plus 2 by x minus 2 dx. This is equals to x minus 2 by x minus 2 is 1 plus 2 by x minus 2 dx. So integral 1 dx is x plus 2 into integral 1 by x minus 2 dx is log x minus 2 plus constant of integration c. This is y by x into x minus 2. So this itself is the required general solution, but he is asking to find the particular solution at x equals to 3 and y equals to 9. So put x equals to 3 comma y equals to 9. In this we'll get y value is 9 by x into x minus 2. 3 into 3 minus 2, which is 1. This is equals to the value of x is 3 plus 2 log 2 minus 2, 3 minus 2, which is 1 plus c. So this is 3 times, this implies 3 equals to 3 plus log 1 value is 0. So 2 into 0 is 0 plus c. Therefore c equals to 3 minus 3, which is 0. So substitute back in this equation, then we'll get y is equals to x into x minus 2. If you transpose onto another side, x into x minus 2 plus x into x minus 2 into this is x plus 2 log x minus 2. Here c is anyway 0 we got. Therefore this itself is the required particular solution at the values given. This is example number 9 from the textbook. Solve 1 plus y square dx is equals to tan inverse y minus tan x dy. So here dx by dy equals to tan inverse y minus x by 1 plus y square. Otherwise, if you write dy by dx, then 1 plus y square by this. So actually we cannot do any further from that. So this is equals to dx by dy. So this is minus x by 1 plus y square. This is equals to a minus b by c tan inverse y by 1 plus y square minus x by 1 plus y square. This minus x by 1 plus y square, if you transpose here, this is plus x by 1 plus y square is equals to tan inverse y by 1 plus y square. This can further be written as dx by dy plus 1 by 1 plus y square into x equals to tan inverse y by 1 plus y square. So this is clearly of the form dx by dy plus px equals to q. This is case 2. Here p equals to 1 by 1 plus y square and q is equals to tan inverse y by 1 plus y square. So therefore integral factor is e power integral p dy. E power integral p is 1 by 1 plus y square dy. So e power integral 1 by 1 plus x square dx is tan inverse x. Here it is tan inverse y. Now the general solution is starting with x here, not y. So had it been dy by dx, we should start with y. But here dx by dy, we should start with the x. X integral factor is equals to integral q into integral factor into dy. So this is x into integral factor is e power tan inverse y. is equals to Q is tan inverse y by 1 plus y square into e power tan inverse y dy. So, tan inverse y derivative is 1 by 1 plus y square, for which let us take let tan inverse y is equals to some t I'll take. Tan inverse y derivative is 1 by 1 plus y square into y with respect to dy. 1 plus 1 y square dy equals to dt. This is equals to tan inverse y is t into e power tan inverse y is e power t. 1 by 1 plus y square dy is dt. So we have seen integral x e power x dx is e power x into x minus 1. Here e power t into t minus 1 plus constant of integration c x into e power tan inverse y first. So e power, let us replace t by tan inverse y, then we'll get tan inverse y into tan inverse y minus 1 plus c x into e power tan inverse y equals to. So therefore x equals to, let us divide e power tan inverse with the e power tan inverse y on both the sides, then we'll get e power tan inverse y by e power tan inverse y gets cancelled. We are left with tan inverse y minus 1 plus c by e power tan inverse y is e power minus tan inverse y is the required solution. Now let us discuss the Bernoulli's differential equation. A differential equation which is the form dy by dx plus py is equals to q. This is what we have discussed before. This is the actual linear differential equation where p comma q are in terms of x. P comma q are either constants or functions of x. Therefore, to be more specific, dy by dx plus p of x into y is equals to q of x. This is what we have discussed as a linear differential equation. But now the Bernoulli differential equation is along with the function of x, there is a function of y as well. So this kind of a function is said to be a Bernoulli's differential equation. So dy by dx plus p of y is equals to q of x is what we have discussed so far as a linear differential equation, and on the right hand side there is only the function of x. But here, as far as the Bernoulli's differential equation is concerned, so along with the function of x, there is a function of y as well. So this kind of a differential equation is said to be a Bernoulli's differential equation. So first of all, this Bernoulli's differential equation, we have to convert it into a linear differential equation. How? See here, we want only the function of x, but here the mixture of the combination of y, function of y is also existed here, for which let us divide this equation by y power n, so that y power n and y power n gets cancelled. Therefore, the function of x is what we are getting here. So, dividing by y power n on both sides, this is equals to 1 by y power n dy by dx plus p of x y by y power n is equals to q of x y power n by y power n. So this is equals to 1 by y power n dy by dx plus p of x into, this is y power 1 by y power n, a power m by a power n, a power m minus n. This is y power 1 minus n is equals to q of x. So, to convert this Bernoulli's differential equation into a linear differential equation, so we have to take a small substitution. So, in order to convert this in, let us take y power 1 minus n to be some u. Let y power 1 minus n is equals to, I will take it as u. So, let us differentiate this with respect to x on both sides. Differentiating with respect to x on both sides. Then we'll get, so this is 1 minus n into y power 1 minus n minus 1. Y with respect to x is dy by dx is equals to du by dx. This is equals to 1 gets cancelled. Therefore, y power minus n can be written as 1 by y power n dy by dx is equals to this 1 minus n. If you transpose onto another side, it will be 1 by 1 minus n into du by dx. Therefore, this becomes 1 by y power n into dy by dx. This can be replaced as this. This is equals to 1 by 1 minus n du by dx plus this y power 1 minus n is u we have taken. This is p of x into, this is u is equals to q of x. So this is equals to multiplying with 1 minus n on both sides, then this is equals to du by dx plus 1 minus n into p of x into u is equals to q of x. So this can also be written as du by dx plus 1 minus n into p is equals to q. So now this has become the linear differential equation in u. So this is the form du by dx plus pu equals to q. So this is a linear differential equation. So here p comma q are in terms of x only. So therefore, what is the integral factor for this? E power integral p dx. And what is the general solution? General solution is starting with u. U into integral factor is equals to integral q into integral factor into dx and so on. So in this way, we will solve the Bernoulli's differential equation. So likewise, it can be also in another form. What is that? It can also be in another form, which is dx by dy plus px is equals to q into x power n. So this is the general form. A differential equation is the form f dash y dy by dx plus p of x into f of y is equals to q of x. So here x is the independent variable, therefore p comma q are obviously the continuous functions of x. Therefore p of x and q of x. Here dy by dx is associated with the f dash y. Then this can be transformed into a linear differential equation through taking a small substitution. What is that? Let us take this f of y to be u. So then differentiate it with respect to x. Then f dash by dy by dx equals to du by dx. Substitute and the above equation reduces to f dash by dy by dx is du by dx. This is du by dx plus p of x into u is equals to q of x. In other words, that is du by dx plus pu is equals to q. Therefore, this is a linear equation in u and hence it can be solved. So let us try out this problem from exercise 8e that we have left before. So dy by dx is equals to this. Dy by dx is equals to 1 by. So instead of that, dx by dy is equals to x square y cube plus xy. Now this is dx by dy minus xy equals to x square y cube. This is equals to dx by dy plus minus 1 into y. This is minus y into x is equals to x square y cube. So if you see here, this is dx by dy plus px is equals to q. Dx by dy plus px is equals to q. So here p is minus y, which is in terms of the independent variable y. Here q is also y cube is okay, but here additionally x square we can see here. So this is the Bernoulli differential equation case 2 type. So dividing by x square on both sides. Then this is 1 by x square dx by dy plus this is minus 1 by x square into x into y. This is one time cancelled is equals to this is y cube. So this is equals to 1 by x square dx by dy plus minus 1 by x into y equals to y cube. Here this is function of x, this is its derivative. So in order to make or convert this Bernoulli's differential equation into a linear differential equation, we have to take a small substitution. Now let us take minus 1 by x. Let minus 1 by x equals to u I will take. Now let us differentiate this with respect to y. Differentiating with respect to y on both sides. So this is 1 by x square dx by dy is equals to du by dy. Now this becomes 1 by x square dx by dy becomes du by dy plus this minus 1 by x is u, this is y. So this is y into u is equals to y cube. So this is of the form. This is in the form du by dy plus pu is equals to q. Here p comma q should be in terms of y. Therefore see here, this is y which is p here and this is y cube which is q here, and p comma q are in terms of the independent variable y. So here p is equals to y comma q is equals to y cube. Now its integral factor is e power integral p dy, e power integral y dy. This is y square by 2. This is our integral factor. Now its general solution is, start with u here. General solution is u into integral factor is equals to integral q into integral factor into dy. So this is equals to u is e power y square by 2. This is integral factor and u is u itself. What is u here? Minus 1 by x is equals to integral q is y cube into integral factor is e power y square by 2 dy. So now how do you solve this? This y cube can be written as y square into y. I'll split into the same e power y square by 2 dy. Now let y square by 2 I'll take it as t, some other variable. So this is equals to 1 by 2 into y square derivative is 2y dy equals to dt. So 2 gets cancelled. Therefore, y dy equals to dt. So this is what we get. Let us substitute this into this. This is equals to, here y dy is dt into y square is equals to 2t into e power y square by 2 I have taken it as t. So now 2 into integral t e power t dt. So this we know. Integral x e power x dx is x e power x minus e power x. E power x if you take common x minus 1. Therefore this is e power t into t minus 1 plus constant of integration c. So 2 into e power t value is e power y square by 2 into this is y square by 2 minus 1 plus c. So 2 into e power y square by 2. This is y square minus 2 by 2 plus c. So 2 gets cancelled. So this is minus 1 by x into e power y square by 2. This implies minus 1 by x. Let us divide throughout the equation with e power y square by 2. Then this is equals to e power y square by 2 by e power y square by 2 gets cancelled. This is y square minus 2 plus c into this is e power c by this is e power y square by 2. This implies minus 1 is equals to x into y square minus 2 plus 3. 1 by e power y square by 2 can be written as e power minus y square by 2. So therefore this minus 1 if you transpose onto another side, this is 1 plus x into y square minus 2 plus c into e power minus y square by 2 is equals to 0 is the required solution. dy by dx plus x sin 2 equals to x cube cos square y. So here you may see this is the combination of function of x and the function of y. So that is, let us divide this with cos square y. X is the independent variable. Therefore here this is p and this is q. Along with that, p and q are in terms of x. So we may see along with q, which is a function of x, there is also a function of y. So let us divide this by cos square y. Dividing by cos square y on both sides. This is equals to 1 by cos square y is secant square y dy by dx plus x into sin 2y is 2 sin y cos y by cos square y is equals to x cube. So here sin y, here cos y and cos y gets cancelled. So this is secant square y dy by dx plus 2, this is sin y by cos y is tan y into x is equals to x cube. So let us take the substitution. Let tan y equals to u. So differentiating this with respect to x on both sides, with respect to x on both sides. So let us suppose this y to be x. d by dx of tan x is secant square x. So secant square in the place of y, secant square y, d by dx of tan x is secant square x. In the place of x, y into y with respect to x is dy by dx is equals to du by dx. Differentiating u with respect to x du by dx. So this is equals to secant square y dy by dx is du by dx plus 2 into tan y is u. So 2x into u is equals to x cube. So this is the linear differential equation in terms of in u. So therefore du, this is of the form du by dx plus px pu is equals to q, where p is equals to 2x and q is equals to x cube. So p comma q are in terms of x. So x is the independent variable here. Therefore integral factor is e power integral p dx. E power integral p is 2x. So 2 into x dx. So e power 2 into integral x dx is x square by 2. 2 gets cancelled. Now the general solution is start with the u here. U into integral factor is equals to integral q into integral factor into dx. So u into integral factor here is e power x square is equals to q is x cube into e power x square dx. So the value of u is tan y. So tan y into e power x square is equals to, this x cube can be written as x square into x. X square into x into e power x square dx. Let x square derivative is 2x. Let x square is equals to t. 2x dx equals to dt. So this is x square is t here. X dx is dt by 2. So 1 by 2 dt into e power x square is t. 1 by 2 integral t power t is e power t into t minus 1 plus constant of integration c. So 1 by 2 e power t is x square into x square minus 1 plus c. This is e power x square into tan y. So therefore, if you divide with e power x square throughout the equation, then tan y equals to 1 by 2 e power x square by e power x square gets cancelled, x square minus 1 plus c by e power x square is c into e power minus x square. C by e power x square. 1 by e power x square is e power minus x square. Therefore, 2 tan y. So 2 is the LCM here, and if you cross multiply, so 2 tan y is equals to x square minus 1 plus 2 into c. 2c e power minus x square is the required solution. Y square plus x minus 1 by y dy by dx equals to 0. So this is equals to y square equals to, if you transpose on to other side, it will be 1 minus y, 1 by y minus x into dy by dx. So this is equals to 1 minus xy by y. So y on transposing onto another side, it will be y cube into dy by dx. So this is equals to dy by dx equals to, or dx by dy equals to dy by dx. It is being multiplied with 1 minus xy. So if you transpose onto another side, it will be reversed. Dx by dy equals to, this is 1 minus xy by y cube. So this is equals to 1 by y cube minus xy by y cube. This is dx by dy equals to. This implies dx by dy plus this y square times. So this is x by y square is equals to 1 by y cube. 1 by y cube. So this is clearly of the form dx by dy plus 1 by y square into x is equals to 1 by y cube. This is clearly of the form dx by dy plus px equals to q. Dx by dy plus px equals to q. Here, this is a linear differential equation only. It's not a Bernoulli's differential equation because dx by dy plus px equals to q. So here, p comma q are in terms of y. So with y, there is no x here. Therefore, we need not divide with the function of x on both the sides. Now here p is equals to 1 by y square, q is equals to 1 by y cube. So integral factor is equals to e power integral p. P is in terms of y dy. So e power 1 by y square dy. So e power integral 1 by y square is minus 1 by y. So therefore the general solution is, we should start with x here. X into integral factor is equals to integral q into integral factor into dx dy. So this is x into integral factor is e power minus 1 by y. So q is 1 by y cube into e power minus 1 by y dy. This can be written as 1 by y square into 1 by y into e power minus 1 by y dy. So let us take 1 by y's derivative is minus 1 by y square. So let us take minus 1 by y equals to t. Let minus 1 by y equals to t. So then 1 by y square dy equals to dt. So this implies 1 by y square dy is dt. So here 1 by y is minus 1 by y is t. 1 by y is minus t. So this is minus t. E power minus 1 by y is e power t. So this is minus of integral t e power t dt. So we know that integral x e power x dx is e power x into x minus 1. Therefore here minus e power t into t minus 1 plus constant of integration c. This is equals to x into e power minus 1 by y equals to e power t value is e power t value is minus 1 by y into, so this is 1 minus t. If I take this minus inside, then this is 1 minus t. So 1 minus t value is minus 1 by y. So this is minus of minus plus. So c. So this is equals to x is equals to 1 plus 1 by y plus c by e power minus 1 by y. So this is c e power 1 by y. This implies x is equals to y plus 1 by y plus c into e power 1 by y. So take LCM here, then this is y. So xy is equals to y plus 1 plus c y e power 1 by y is the required solution.